Good afternoon, dear colleagues. It's 2 p.m., December 10th, 2020. And we're beginning the panel session for the defense of the thesis by Andrei Sitnikov. The thesis is submitted for the academic degree of the candidate of sciences in physics and mathematics. The specialization is 010403 electrophysics and electrophysical installations. The topic of the thesis is experimental description of the high voltage electric current passage through low conducting liquids based on dynamic current voltage characteristics. I beg your pardon, colleagues, we don't see everyone in the Zoom. Therefore, we have to announce the technical break number 1, so several minutes. So that is the end of the first break. And now you see the rules are quite strict. You need to declare the number of the break, the end and the start of the break. So what should we do with that? So the candidacies of the members of our dissertation board were approved by the order issued by St. Petersburg State University as of September 16, 2020. Andrei Doctor of Sciences in Physics and Mathematics, Professor of St. Petersburg State University, was appointed the chairperson of this dissertation board. Yet, Professor unfortunately fell ill, therefore he is unable to attend the meeting. So, under the order issued by St. Petersburg State University as of December 9th, on the introduction of amendments to the previous order, I, Nikolai Timofeyev, Doctor of Sciences in Physics and Mathematics, head of the Optics Department of St. Petersburg State University, was appointed the chairman of this board. Let me introduce the members of the board, and all of them are working in the remote mode today. Konstantin Yerin, Doctor of Sciences in Physics and Mathematics, Associate Professor of the Department of Experimental Physics of the North Caucasus Federal University. Konstantin, do you hear us and see us? It's okay? Yes? It's okay, I see you and hear you. Anatoly Zhakin, Doctor of Sciences in Physics and Mathematics, Professor, Senior Researcher of the Southwest State University. Professor, do you see us and hear us? Yes, it's okay. Thank you. Sergei Korobeynikov, Doctor of Sciences in Physics and Mathematics, Professor, Head of the Occupational Safety Department of the Novosibirsk State Technical University. Sergei? Yes, yes, I hear you and see you well. And Jerzy Kazimierz Manzarachik, Doctor of Science in Physics and Mathematics, Professor of the Gdynia Maritime University, Poland. Jerzy Kazimierz, I don't see you. Do you hear us and see us? Okay, you hear me and see me. Do you? So the connection is poor. So, Jerzy, do you see me and hear me? Professor Mazarachik? So, Professor does not see me and hear me. I believe we have to announce the second technical break until we restore the connection with Professor Mazarachik. Usually we don't hear you. We see you, but we don't hear you. Do you hear us? Professor, you hear us? Yes? Do you?
Well, what does it mean, us? I can hear you.
So you hear the interpreter? Yes. You don't hear the you don't hear the colleagues. You hear the interpreter. Yes.
Yes. Well, there is a background.
Okay.
Some background. I can't understand anything. Not because of Russian, but the voice from the room is very low. But I hear you very well. Hello? Hello?
So let me introduce the members of the board with us. So here we have the candidate for the degree, Andrei Sitnikov, and also we have the thesis supervisor, Professor Vladimir Cherkov, PhD in physics, associate professor of the radio physics department of St. Petersburg State University. Distinguished colleagues, in order to improve the quality of our connection, if you are working in the remote mode, kindly turn off your microphones so that the sound won't interfere, and don't forget to turn them on when I give you the floor. I would like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and the session of the panel session is also interpreted into English and vice versa. Currently we have an email address posted on the page with a live broadcast of the board session, and all listeners can submit their questions and opinions to Mr. Sitnikov online. The questions regarding the thesis or the scientific discussion. The questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the presentation and the content of the thesis, and do not forget to give your name and position if you submit a question. And the questions that have nothing to do with the scientific discussion or dissertation will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by the local normative acts, the session of the dissertation board is valid, providing 2/3 of the appointed members are present. The total number is not to be fewer than 4 people. The dissertation board consists of 6 people, anyone 5 are with us today, including 4 members of the board that are working remotely. We have a multimedia connection with all the members of the board, as well as with our candidate for the degree and the thesis supervisor. Therefore, we have a quorum, and we can hold our meeting. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Chairman's replies to questions, if any. Next comes the candidate's presentation, providing an overview and findings of the research, 15 minutes. Third, questions to the candidate regarding their presentation, no more than 10 minutes for each question. Then, a candidate's replies to the questions, no more than 10 minutes for all the questions, but it's hard to regulate it, certainly. 5, reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions. 10 minutes per speaker here. 6, the chairman's report on the thesis. 10 minutes as well. 7, the candidate's comments about the reports on the thesis and replies to the questions. 8, open discussion. Anyone present at the defense may state their position or ask questions on the thesis. And everyone willing to speak out, kindly fill in the registration form and introduce yourself before you have the floor. Next, the chairman will ask the questions submitted during the broadcast via our website. 10, the candidate's replies to the questions. 11, presentation of the candidate's thesis supervisor. Next comes 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. Then, next comes open balloting, vote counting, and recording the results in the protocol. Then, making a decision on whether to confer the academic degree or not. And finally, the candidate's closing remarks. Distinguished colleagues, any questions or comments on our agenda? I believe none. Okay. So let us proceed. And so, let me start. The chairman's presentation. The thesis by Andrei Sitnikov for the academic degree of the candidate of sciences in physics and mathematics. The specialization 010403, electrophysics and electrophysical installations, is titled Experimental Description of the High Voltage Electric Current Passage through Low Conducting Liquids based on Dynamic Current Voltage Characteristics. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued September 16th, 2020. Mr. Sitnikov has prepared his dissertation based on St. Petersburg State University. And Vladimir Cherkov, PhD in physics, associate professor of the radio physics department of St. Petersburg State University, is the dissertation supervisor. The list of 6 published works describe the research findings. They include 6 papers indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the academic secretary. The above mentioned documents comply with the requirements of outlined by the order on the procedure of granting academic degrees, and the documents, as far as I understand, correspond with the requirements and are found in the certification file. And the curator of the defense, member of the Department of the Dissertation Board Support, has the copies. And before I give the floor to our candidate for the degree, distinguished colleagues, do you have any questions to the candidate for the degree? Is there need to consider the list of documents provided by the candidate? I have no questions. No questions. None. Thank you, Professor Mizrachik. What about you? Any questions?
No questions. Thank you very much.
So, Andrei, please, you have the floor. Your 15 minutes. Thank you. Distinguished colleagues, good afternoon. My name is Andrei Sitnikov, and I would like to give you a review of my dissertation work, Experimental Description of the High Voltage Electric Current Passage through the Low Conducting Liquids based on Dynamic Current Voltage Characteristics. Low conducting liquids are weak electrolytes with specific electric conductivity of 10 in -6 degree, and high voltage conductivity is not a characteristic of the liquid but of the entire system overall. Thus, it depends on the geometry of electrodes and on the applied difference in potential. The main problem here is lack of a universal mode of description of high voltage passage, and taking into account the fact that it is mostly represented as a non-stationary process and depends on the applied difference of potential and on the time of impact. And the standard approach to the description of this process is the use of the intrinsic conductivity, low voltage conductivity of the liquid. And sometimes we use current voltage characteristic and really use current time characteristic. For example, current voltage characteristic does not have a resolution on voltage, and the second one has no resolution in time, and two drawbacks can characterize the intrinsic conductivity of the liquid. And an alternative here is the dynamic current voltage characteristic, that's the dependence of current on the voltage during the change of the latter. It has no such drawbacks, but it is rarely used due to its complexity of acquisition. Thus, the goal of this research was to check the opportunity to use the dynamic current voltage characteristic for experimental description of high voltage current passage. In order to achieve the goals, we've outlined the following tasks. First of all, to detect the basic characteristics of dynamic current voltage characteristic using numerical modeling, then find a convenient and quick mode of defining the capacity of a component. We should compare the numerical and experimental results in most simple cases, and after that get dynamic current voltage characteristic for real liquids and give an interpretation of the received results. One of the auxiliary methods of this research is numerical modeling based on the following system of equations and correlations. The main uncertainty in this model is this marginal condition on the surface of the active electrode, namely the function of the production of particles or injection function. And in literature we don't have the universally accepted theoretical type of this dependency. Therefore, in this study we chose the function that we received using the methodology of the restoration of the injection function. And we should start our consideration with a simpler case, passage of current at permanent voltage in unipolar injection. After the voltage is turned on, we see the injection to liquid, and at some point the charge moves to counter electrode. That's by electrohydrodynamic movements forming a jet, and that is the peculiarity of high voltage current passage in low conducting liquids. Therefore, it spreads along with the movement of the liquid, and as the jet spreads to counter electrode, we see the rise of the number of carriers of the charge, and this corresponds to the first range of current voltage characteristic. Then we see quasi-stationary range, and at some point the ions start to move by counter flows to the volume of liquid, and it leads to their accumulation in stagnant areas. It leads to screening of the electric field and to reduction of integral current values. And there are specific characteristics here for current voltage characteristics, but if we summarize, they all are considered from the point of turning on up until some decimal points of second, and therefore there is a problem in the experimental studying. Now let's shift to the linear changing voltage. And today time is connected with voltage, and as the time grows, we see the growth of the area of injection. And as for the this characteristic, we poorly see the slot of the formation of the charged jet. But still, we see the second lengthy process, the process of accumulation of the charge in volume. And there's a difference between instantaneous values on the increase and decrease branches. When we see the rise of modulation speed, the hysteresis drops, and if it drops, the characteristic shifts to its stationary version. For different mechanisms of charge formation, we see certain peculiarities on dynamic current voltage characteristic. If we inject to non-conducting liquid, we see a lack of linear area and early start of non-linear range. And usually we see the hysteresis, the difference between linear and counter flow of characteristic caused by the accumulation of the charge in the stagnant areas. And for dissociation, see this linear range pronounced. And in case of this blade plane system, electron system, we see that the increase of intensity of dissociation, and here we should have rather high intrinsic conductivities of liquids. And now let's shift to experimental part. Measuring the experimental data, we can face the following problem. The capacity current is rather small, 10 nanoamperes, with characteristic values of the capacity of the system and the speed of modulation of the voltage. However, in cases when we have very low conducting liquids, this current can be comparable with the current that flows through the cell. And theoretical calculation is rather problematic because it depends not only on the dielectric permeability of the sample, but also on the allocation of the electrodes, and it requires three-dimensional modeling. In order to simplify, we've written a specific program that calculates the capacity based on the voltage impulse that is rather small to cause intensive current passage through the volume of the cell, but it's rather sharp to cause this capacity component of the current. And therefore it's easy to calculate the capacity, and we extract the capacity current. Therefore, we get. Therefore, it's quite easy to analyze and to get experimental data. The process of acquisition of the reproducible experimental data is more complicated. When we have mechanical inclusions, they can have conductivity that is higher than the conductivity of the liquid, and thus they act as the carrier of the charge, and they can stick to an electrode, acting as its continuation. And on this graph you see the example of current time characteristic for the latter case. The filaments can stick to the active electrode, increasing the high voltage mechanisms of charge formation, and this leads to instabilities. On dynamic current voltage characteristic, this process is also obvious. We see the rise of current values, and then the current drops, and the latter part of the rise of characteristic combines with the drop of characteristic, and the characteristic becomes smooth. And this can be explained by the fact that the filament was shaken off from the electrode, and this problem has no solution practically for a classical dynamic current voltage characteristic or for current time characteristic, but in case of dynamic current voltage characteristic, it can be resolved by a shorter impulse of voltage, during which the particles won't be able to get to this inter-electron gap. Another problem is the stability of the active impurity. In order to improve the conductivity, they add different spirits, and they are rather volatile. Therefore, they can evaporate from a non-hermetic cell. And this process is irreversible regardless of the measured characteristic, and for different points of time, they won't coincide. In case when we have very low conducting liquids, the charge does not relax in volume, and this leads to a specific peculiarity, the impact of history. The first curve was acquired after the application of several impulses, and the second and the third one after the discharge of the liquid. And we see that the discharge allowed us to get reproducible data. As with model data, when we have sufficient small speed of modulation, the dynamic characteristic starts to coincide with the stationary version. And one of the peculiarities of dynamic current voltage characteristic is hysteresis, and mostly that's quite a complicated thing. If we talk about current time characteristic, the change in current is observed with a fixed difference of potentials. In the dynamic case, the difference between the values of current on the branches of increase and decrease can be much higher, and that is connected with the fact that in volume we may have the charge that was formed at a higher difference in potential. And on this graph you see the experimental data for the needle plane in case that we used a liquid petrol atom. And we see that the shorter the impulse, the higher the characteristic, and the longer the impulse, the lower is the characteristic. And in order to demonstrate that this effect is connected with the accumulation of the charge in this stagnant area, we carried out special modeling. We restored the geometry of electrode and the injection function was chosen so that the current flows would coincide with the experimental ones, and we see that the resulting characteristics are comparable to the experimental ones. The presence of two parameters, voltage and the time of change, allow us to describe high voltage current passage in more detail than the classical dynamic current voltage characteristic or CTC. And an example here is the study of heated samples. In such cases, usually we use thermostats to support the external conditions. But for conducting liquids, we see a vice versa situation. The passage via the volume of the cell can cause Joule heating. And this in turn leads to an inability to organize long-term measurements. And most frequent problem to study the samples with the injection mechanism of charge formation is the degradation of the metal-liquid pair. And on this graph we see the dynamic current voltage characteristics for blade plane system, and here we used olive oil. And we see that the dynamic characteristics allowed us to get a more distributed in voltage and time picture of the process. And comparing this characteristic with the other one, the dynamic one the current time characteristic demonstrated the drop here, but it won't demonstrate the change in the linear area. And current voltage characteristics won't be informative because it has no time regulations and the periodicity regulations. And if we measure stationary version, all the changes would be missed, and we would get a curve that coincides with the fifth curve. And intrinsic conductivity is not measurable in vegetable oils because they have a lot of acids, and at small voltages we observe electrochemical injection that deviates the results, that distorts the results. And one of the applications of dynamic volt-ampere characteristic is the methodology of the restoration of the flow of injection flow. And this characteristic is strongly dependent on the liquid and metal and on the geometry. Here we offered a specific system of electrode blade plane. Early experiments demonstrated that with equal conditions in this system we observe the stable flows, more stable flows, yet it has certain drawbacks as well. The systems with extended electrodes, it is taken for granted that they have translation symmetry, yet it was not demonstrated experimentally. I restored the kinematic structure in the central part, and it turned out that this quasi-homogeneous flow area makes up just 2 centimeters in the central area of the cell. And in order to eliminate this peculiarity, the plane was divided into 3 parts, and the side ones were earthed, and the current was measured only from the central 3. And on this graph you see the characteristics for the transformer oil with an admixture of cyclohexanol, and we see that for different polarities, only the parts of characteristics are different, and it means that there's non-symmetry of high voltage mechanisms of charge formation and the presence of injection in positive polarity. On this data we demonstrate the work of the method. In this method, initially we offer to define all the parameters of the system, including the cell geometry. After that, we get the solution, from which, depending on which we select the test dependency. And we calculate the current that flows through the active electrode surface, and we look for dependency as a sum of polynomials, and all the insignificant members are taken out to reduce the number of selected parameters. And when the dependency starts, or the model characteristic starts to coincide with the experimental one, we organize full calculations in order to calculate the impact of injected charge of and at that the characteristic drops, goes lower, but when we repeat the full calculations, we can achieve rather good coincidence in the results. And in order to verify this methodology, we compare the experimental data and the modeling data. And it's obvious that the data coincide in the central area of the jet, excluding this acceleration and slowdown of the liquid area, because here experimental methodology gives rather huge error. Thus, based on the above-mentioned results, we have the following conclusions. Regardless of the complexity of the dynamic current voltage characteristic, it is reproducible. In the presence of 2 variable parameters, the voltage and the change rate, allows us to get a characteristic in the broad range of voltage and with different times of impact. The difference between the increase and decrease branches is the demonstration of the presence of relaxation processes. And a vivid example here is the presence of hysteresis during the accumulation of the charge in stagnant areas. And in the domination of injection mechanism, dynamic current voltage characteristic is applicable to restore the function of the density of injection flow depending on the electric field intensity. That's it. Thank you. Thank you, Andrei. Questions? Dear colleagues, any questions on the report? Andrei, I have one question. Certain experiments, for example, figure 21, took too much time, tens or even hundreds of hours, and this latter curve, the 5th curve, was taken after 220 hours. So could you please tell me, how did you provide equal conditions and control over the conditions in such lengthy experiments? So, periodically, when we measured the characteristics, we measured the temperature using the inbuilt meter. The conductivity was controlled visually, comparing the linear areas of characteristics, and we had visual control so that there were no inclusions, mechanical inclusions, that would interfere in such a conductivity. So you can say that the conclusions that you made from these experiments are cannot be questioned by some incompliance and insufficient control of the conditions. No. Okay. Other questions, if any? I have one. My question is connected with the remarks. There is no sound. How did you set the marginal condition of the discharge of the ions on counter-electron? So the discharge conditions were set as migration and diffusion components. So that was the imitation of free passage of the charge, or the entire charge that went to the electrode to the counter-electrode was eliminated at once. And a comment. This effect is possible only in water electrolytes, and at that the charges can be discharged instantaneously. In liquid electrolytes, they are not discharged instantaneously, they accumulate, and this is one of the problems of the long life of such systems, the accumulation of charges on counter-electrodes. That is a significant problem that was not resolved up until now. Thank you. Do you agree? Okay. Yet another question. What were the times that you calculated on consoles? Yes? Yes. That's a direct scheme. The iteration in time. And what time period did you take? Is it comparable with the times of impulse that you organized in your experiment? Is it comparable this period of time? Is it comparable you mean the step of time? Yes, the time of calculations should be comparable with the time that you set in your experiment, because you had this dynamic current voltage characteristic. For example, you set the impulses and yes, triangle impulse. Does it coincide with the time of calculation in your numerical modeling? In numerical modeling, we set the same time of modulation as in experiments. Okay, and did you monitor that the electrodes managed to get to counter-electrode, this accumulation process of injection charge? Did it happen or not? Yes. If we consider injection, then part of the charge was accumulated in the stagnant areas, and it's not eliminated. It does not die out on the electrode, so they are accumulated. Okay, I got it. And the last thing, the choice of the model. How did you explain it? So the ions that are dissociated, they are generated on counter-electrode. Why did you choose this model? Yes, I got it. I got a question. In this case, we simplified in order not to create some additional equations. For example, in order to take into account a different sort. Because those values of movement that we used, they were received from the reference materials. And this movement of injected ions is something that we didn't know. Therefore, it was an approximation. Okay, but if it is an approximation, so how can you say that you define using the numerical modeling is that you define injection or functions if this model is approximate. Yes, I got your question. Thank you. We do not define the function exactly. That's a 100% approximated function, and we do not even say how many injection functions can be demonstrated there. We try to use a polynomial to describe the entire function, overall, all the functions that we have. So that's an integral value that sums up all the processes that happen in injection. Yes, the thing is that we have to describe all the processes of this function in order to use this function for approximate design. We don't say that this model will be 100% will 100% describe the processes that take place, but it should give specific characteristics, or it should demonstrate them. And the last question. In your report, you didn't give the values of the electric intensity, electric field intensity on the injected electrode. What are the values of intensity of the electric fields present here in the injection process? The values. Well, it depends on the system of electrodes that we consider. For example, if we consider the system of electrodes on the needle plane, here we see this sharp tip, and we achieve this model with a insignificant curve. Here we see very high fields, 10 taken to the 8th grade volt per meter. So that's 1 megavolt per centimeter. Do I get it right? Yes. So in such fields, the liquid molecules just burst, because these are the fields that are comparable with interatom fields. And at that, we see ionization of the liquid. And that's not an electrochemical process. That's a physical process of ionization of liquid, and these fields are huge. And in such fields, we may have very complicated processes up until gas formation. And our model covers just the case with liquid and ion formation in liquid. The increase of dissociation with electric field was considered using this graph. So this data, well, the strengthening of dissociation with an electric field was taken into account, but as for additional processes and effects, they are not included in this equation system. Therefore, in the modeling, we did not consider them. Yes, I get it, but I once again say that in your experiments, the injection process takes place with a burst of molecules, and as the hydrogen molecule is complex, we form the entire complex of ions, not those ion pairs that are formed, but the entire complex of ions, and that's quite a complicated process. We take into account that each liquid has soluble gas, air, acids are formed there, and different complexes, and if we take into account the fact that the surface of the electrode takes part in this interaction, we may have complex ions and so on and so on. So this process that you study in your experiment, it does not correlate with the model that you used. Yes, I get the question. In this modeling, I wanted to demonstrate the basic characteristic peculiarities that emerge when we measure dynamic current voltage characteristic. And here, injection is formed not in the specific volume and in the point, as in case with dissociation, but on the surface. And we see the hysteresis here, and that is the basic element. And in order to take hysteresis into account, that we have it, and in order to demonstrate it, you don't need to have such a significant mathematical model. But certainly this would be a good improved model, and certainly that will be a good point for further studies. I have no questions. So, Anatoly, are you satisfied? Yes, I understood the answers, and as for satisfaction, that's a matter of discussion. Okay, other questions, if any? I have a question inspired by Anatoly. So you've taken the injection function as a polynomial. And do you have a physical substantiation where you took it? Or it's easier to describe like that, and let us do that. Yes, I got the question. And I will answer in details. There is a set of representations about how can the function of injection look like, and basically it is represented in the works of Anatoly Ivanovich and this table of types of injection. And in different works on computer modeling, we use sometimes constant injection and sometimes the linear one. Therefore, here I didn't have any physical importance of injection. The injection was not chosen according to specific physics and chemistry process that takes place on the electrode. We've chosen polynomial dependency in order to describe the processes in the volume. So the mathematical approach. You've seen it? Yes. So no physics here. Yes, that's what I'm talking about. This approach, you see, you could have had different electrodes or liquids. You can't summarize it if you don't have physics in this approach. Yes, but in this approach, this methodology can be used right now for approximate modeling. Yes, for a specific system, transformer oil, where you drop cyclohexanol. And according to the electrodes that you used there, well, this function should give us those currents that we observe in experiments. Therefore, if we manage to restore the approximate function, it does not mean that it won't work for other system of electrodes with the same electrodes, with the same metal and with the same liquid. And it doesn't mean that it will. Well, unfortunately, in this work we did not check it, but there are prerequisites to think that it will. Well, the physics substantiation is something that you should have, as far as I see it. That's it. Thank you. Thank you. Thank you, Sergey. Other questions, if any? Nikolai, let me ask a question. Yes, Konstantin. That's just an experimental interest for me. Andrei, could you please tell me, on slide number 7, in the file that you've sent out, there is this figure 9, the description of experimental method of the acquisition of the dynamic current voltage characteristic. Yes, open it up. Yes, that's it. Could you please tell me, as far as I know, before submitting this linear growing voltage, you submitted short impulses to the system in order to define the electric capacity of the system and then take capacity currents into account. Unfortunately, here this black impulse is not seen well, but it's still understandable what kind of form it has. So I have the following question. It's rather low voltage as far as I see it compared with the main impulse. Could you please tell us, have you carried out the assessments, or maybe you have certain understanding whether we have the change of system's electric capacity when we submit high voltage? Certainly the geometric parameters do not change, but as for the electric permeability of the liquid, that you tested, can it change? Because there is this partial dissociation of molecules, and what impact does it have? Is it a strong impact? Maybe you've taken that into account. I can tell you about how we checked that this does not happen, or the impact is insignificant. In the characteristic that we measured, and initially the current that we measure, it has a lot of capacity current that was calculated numerically. And when we distract it, it turns out that we distract the constant in those areas where it should be the constant. And it turns out that if the capacity would change, the current value that we would distract on the increase and decrease branch that we distract, it would be fixed due to the fact that we've chosen the constant. But if the capacity would change, in fact, we would see the gap in the maximum of voltage, because in this case we would distract the incorrect value of the capacity current. And if we don't see this gap, it means that the capacity indeed did not change when we held our experiments. Thank you. Thank you. Other questions? And why gap? Why not change? Gap because we distract a specific vector of values. And if we distract from a characteristic that has this gap, and when we deduct this capacity current, it won't be taken into account correctly. For example, the capacity grows, then we will deduct insufficient current so that this gap that is present here would go. And if the capacity is increased, the current that we're going to deduct is the one that we calculated on the derivative of voltage, because the derivative of voltage, regardless of the capacity of the system, is fixed. So so you judge by the smoothness of your characteristic. If it has no drops, then it means that you've deducted correctly. No. No, we're considering different criteria that the capacity was calculated correctly. First of all, we have this voltage impulse, and we compare the derivative of voltage with the current that goes through the system. And they should repeat each other on this voltage impulse, because we introduced that the current that passes through the system in our model is described by capacity. And then we deduct this calculated value of capacity from the current maximums and voltage derivative, and this is just a secondary verification of the fact that we've calculated it correctly. If we would see certain gaps here, then the modernization of the method would start. Yet another question. An experimental one as well. Did you use different electrode materials when you held these experiments? And if yes, then what are the peculiarities? What is the dependence on the material of electrodes, for example, made from one metal and plane from another metal? The plane, for plane we used steel, because we presume that there is no active injection of the charge to the liquid from it, because the field is rather low of this plane. And as for the tips, the sharp electrodes, we use different materials: copper, chromium, steel, And there, if we observe injection mechanism, then it is dependent on the material of the electron. And overall, this difference was visible. Okay, any other questions? No questions. Okay, thank you. Natalia, any external reviews on our online? From our email? No. Okay, now we shift to the reports of the members of the board with their reviews. And first of all, I would like to give the floor to Konstantin Yerin. Please, Konstantin, you have the floor. And I asked not to read the entire review because all the reviews were published on the St. Petersburg State University website. Therefore, just your comments and just your remarks. Thank you very much, distinguished Nikolai Alexandrovich, distinguished colleagues. Indeed, I'll try to be short, and I will give just an overview. Certainly, the topic on the study of electric conductivity of dielectrics is not a new one, but I believe I won't exaggerate too much if I say that these studies are carried out for 150 years already, and there are hundreds of review articles published in this field, and there are well-known monographs, and we see the formation of quite a stable understanding of the mechanisms of charge transfer in liquid dielectrics, and a range of methods of studies were developed, but certainly the creation of an improved experimental methods on the study of the flow of electric current that allow us to detect different factors that may have an impact is an important task for electrophysics, and in this regard the work of Andrei Sitnikov is quite relevant. As far as I see it, the dissertation has a rather classical structure: the introduction, 5 chapters, conclusion, the list of abbreviations, literature sources, and the introduction in chapter 1 are quite traditional. I won't dwell upon them. On the second chapter, that is dedicated to the description of the methods, I would note the dynamic current voltage characteristic that and the author also devised the methods of consideration of the multitude of factors that complicate the holding of studies of electric conductivity in liquid dielectrics, and at the same time an advantage of the dynamic current voltage characteristics is the simplicity of their measurements and the simplicity of instruments used. In chapter 3, the author took into account the factors that may have an impact on the passage of current in low conducting liquids, in heterogeneous fields, and in changing voltage. They also offers the methods on the resolution of goals if we want to calculate the input of other components. In chapter 4, author analyzes the methodology, and the author demonstrates that such characteristics are the full-fledged way to assess the high voltage current passage. In chapter 5, the author gives the methods for the restoration of injection function of the charge based on the dynamic current voltage characteristics, and this method combines modeling and experiment, and it allows to restore the injection function and get the correct distribution considering the data on the movement of ions. Overall, the thesis made a good impression. The results are seen as new ones. They are described in detail. There is a comparison with the data of numerical modeling, and the results are recognized in the scientific community, and the author delivered several reports at the international conferences, and in Russia the author published 6 articles in the journals indexed in the Web of Science and in Scopus. And as any serious work, the dissertation of Andrei Sitnikov has certain may arise certain comments, and 3 of them were already reflected in my review. The first comment: the description of the contribution of the capacity current in the change of the dynamic current voltage characteristic is quite laconic, and it does not allow us to specify certain details. So you don't explain the nature of this rise of current on figures 2.1.2 and 2.1.3 and a moment of time of 3 seconds, and there's also no we can't understand the changes in this capacity current at the time of 8 seconds. And then in analysis of current voltage characteristic, figure 3.1.4, you detect the quasi-stationary load from 5/100th to 3/10th seconds, and the ion current does not change here, and it is substantiated by the graph on the neighboring figure, and the interval of time here does not change much. And this effect can be explained by the partial screening of the external field by a space charge that is accumulated near the tip. But here you see this figure 3.1.5a, and we can see that within this interval of time, the space density of the charge grows 5 times. And it would be interesting to learn your opinion on the nature of this quasi-stationary range and its connection with the growth of the density of the space charge. And yet another comment: regardless of the fact that the graphic material of the dissertation is performed rather with high quality, there are certain difficulties when we need to divide this graph that represent the results of experiments and the curves that were received after calculations. For example, I have such a problem with figures 3.17, 3.111, 3.114, 3.31, 3.36, and others. If these are experimental data, then for what samples and for what conditions were they received? What are the mistakes in these experiments? And if these are the results of modeling, then what are the calculation parameters that you got them with? Still, my remarks do not compromise the high value of your results, and these are rather recommendations for further development of work in this direction. And as far as I see, the results are quite credible, and they are significant, important for science. And the conclusion, the thesis of Andrei Sitnikov, entitled Experimental Description of the High Voltage Electric Current Passage through Low Conducting Liquid based on Dynamic Current Voltage Characteristics, meets the requirements of the Order of St. Petersburg State University on the procedure of granting the academic degrees at St. Petersburg State University. And as far as I believe, Mr. Sitnikov deserves the academic degree of the Candidate of Sciences in Physics and Mathematics in Specialization 010403, Electrophysics and Electrophysical Installations. And at that, Article 11 of the above-mentioned order is not violated. Thank you very much, Konstantin. Andrei, please answer the questions. Thank you. As far as I remembered, there was a question on this impulse of 3 seconds. Yes? On this graph we don't see that, but for these, for data in real experiment, the impulse, a voltage impulse, was not ideal triangle, but with a small rise, and this step on 3 seconds correspond with this step in voltage. That is it. Yeah, that's clear, but on the graph in your dissertation and on the graph that you've demonstrated in your report, we couldn't see this step of voltage. Therefore, it was not clear why there was such a huge step of the derivative. Yeah, that's a kind of mistake. Just to save time, to save the space, I've overlapped these graphs, and therefore part of information was missed. And as for quasi-stationary range on ampere-second characteristic, this period of time, the charge that reached counter-electrode starts to spread along the plane. Thus, it spreads counter the field lines, and it doesn't have an impact on the intensity of electric field of the electrode, so it does not influence the function of the generation of particles. And in other periods of time, it fills out the entire plane and starts to move backwards to the volume of the liquid. That leads to accumulation in stagnant areas and to reduction of the electric field intensity that corresponds with the last point over here. So quasi-homogeneous and quasi-stationary lot is connected with the fact that the charge grows due to the fact that it spreads along the plane, yet it does not have a significant negative effect on the current characteristic. So I answered this question, and there was yet another question on the figures. Yes, I beg your pardon for that. Indeed, I tried to correct that in my presentation and to write down what graphs are experimental ones and what are the modeling ones, and I'll try to take that into account in my future works. Thank you, Andrei. Konstantin, are you satisfied? Yes? Yes, quite satisfied. But there is this tradition, you know, when you give experimental data on the graph, you need to, well, somehow demonstrate the range of error, and therefore there are no questions. When you have calculation curve, then certainly there are different requirements for that. So unfortunately you didn't show it everywhere. Yes, let's hope that in future works Andrei will bear that in mind. Okay, and now I give the floor to Anatoly Zhakin. Please, Anatoly. So in my review, I analyzed the work in detail, and I would also like to mention the relevance, novelty of studies, and I'll shift to the comments that I've already written in, that I've already voiced. The first comment. The author makes a provision that one of the types of ions formed in the volume at dissociation is also formed in injection process. So we've already discussed it. And now we understand that injection process in experiment, we see a lot of charge due to the fact that hydrocarbons are quite complicated systems, especially transformer oil. It has admixtures against the wear-off, and transformer oil depends on the type of oil that it's produced, aromatic hydrocarbons and others. Therefore, it's hard to predict what may form there in such strong fields. Therefore, it's clear that the model is not an adequate one. Anatoly, I beg your pardon. When one of the members of the board leaves, we need to declare technical break number 3. Okay, let's wait for Professor Mizrachik because he left somewhere. He will come. Yes, I hope. So the technical break number 3 is over. So Anatoly, please continue. So the first question we already discussed it. Second comment. In the systems of equations, you do not describe this function of the death of injected ions on counter-electrode. And that is a significant point because the author in the description of experimental data, so you are talking about discharges, and you believe that there is no discharge on the surface of the electrode. That is a dubious question. And as far as I see it, in liquid dielectrics, there are special electrons, and the process is quite complicated. The process of transfer is not just connected with ion conductivity, but with electron one as well. So that's quite a specific electron conductivity because the electrons are not free, but rather surveyed. And this is the question that I formed. It's rather a complicated one, and it is a topic of a separate discussion. And certainly you can define these marginal conditions, but this won't give us too much information. Now, as for other remarks, in chapter 3, you don't correctly formulate the marginal goal, and certainly there is the connection to a specific electrode system, to the material of electrode, and to a specific liquid. It was already mentioned by Sergei. Because summarizing the results is something that you can't do. And that's not my point of view. It's universally accepted that in liquid dielectrics, the universal theories of electric conductivity is something that you cannot create because they have quite varied physical and chemical characteristics, and each liquid requires its own theory. Now, the next comment to chapter 4. You could have given elementary physical assessments that would allow hysteresis on needle. And once again, I would like to repeat that this fields that you have on the tip, it can be comparable with interatom fields. Therefore, you have the accumulation of the charge of the same polarity, with the polarity of the needle, but explaining what kind of charge is that and how they move. It's quite complicated because we do not know what kind of charge emerges there. Therefore, explaining hysteresis in modeling is something that you cannot do as far as I see it. And the fact that you have experimental data, this will demonstrate that you have certain ideas to voice on the mechanism of the hysteresis. And as for chapter 5, I would like to emphasize once again that numerical modeling is insufficient to explain the experimental data due to the fact that the real processes are something that we do not know. And you should have made an emphasis on a specific liquids. You could have taken one liquid and study all the processes fully. Electrochemical injection from the point of view of microscopy, and current transfer and discharge conditions. You shouldn't have taken different types of oils, petrolatum, oil, and so on and on. And because overall, we don't have overall regularities. We have this regularity with specific liquid, with specific physical and chemical characteristics. And as for my summary, I believe that the author devised new method of the measurement of dynamic current voltage characteristic in its application to liquid dielectrics. Because this method has long been known in electrochemistry, but it is called otherwise. So when they measure the potential of the electrode on which you see electrochemical process, and that's a change of potential that is changing in time. And these methods are really similar, but there you measure the potential of the electrode, and it gives a lot of information about the electrochemical act, about the process of charge formation on the surface of the electrode. And this is the method that we know in electrochemistry, and it is quite frequently applied. And here you used it in high voltage fields in liquid electrics. And it's very important, I believe, that the development of this method will give us a lot of information on the mechanism of ion formation in super strong fields. As for the practical value, it was already mentioned. The possible application was already mentioned. We can study the accumulation of energy, and so on and on, the use of impulse fields. So overall, that's a separate topic for discussion, and I believe that the practical value is something that we have in this work, and if we think well, we can introduce this method somewhere. As for my recommendations, I have already listed them, that these results can be used in any university, and we can give this information to the broad strata of scientists. And the conclusion is that the thesis, titled Experimental Description of the High Voltage Electric Current Passage through Low Conducting Liquids based on Dynamic Current Voltage Characteristics, meets the requirements of the order as of September the 1st, 2016, on the procedure of granting academic degrees at St. Petersburg State University. And the candidate for the degree, Mr. Sitnikov, deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 010403, electrophysics and electrophysical installations. Article 11 of the above-mentioned order is not violated. Thank you very much, Anatoly. Thank you very much, Andrei. Please answer. I believe I'll start with the methods, with methodology. As I've already mentioned, this methodology does not represent the methodology of the restoration of exact or functional dependence, and it just outlined that the function is searched for in a quite approximate manner. Therefore, it can be applicable in case that we need to restore the function for such approximate design of the system. And as for the improvement of the mathematical model used in this research, yes, this model should be improved in order to understand the processes better during the generation, near electrodes and on electrodes, and we should also take into account the possible changes of the area and in behavior on the areas of elimination of electrodes, on electrodes. The most important thing in this method is that it was demonstrated as an example of the application of the dynamic current voltage characteristic. And due to the speed, due to the due to this difference in voltage and this short time period, we can use it in such methods. So what were the other questions? You need to remember the questions that you are being asked. Yes. So on all chapters, 3rd, 4th, and 5th. Okay. As for chapter 3, on current time characteristics, the processes that take place in liquids at permanent voltage are different. No, they are not significantly different compared to the impulse inclusions. And is it possible to give a summarization of the results of computer modeling? For example, of experimental data for the different electrode systems. And in this work, we demonstrated that certain types coincide in the blade plane and in the needle plane. If we talk about the hysteresis in injection mechanism of charge formation. Yes, maybe in case of the needle, these processes have some additional mechanisms of charge formation, yet overall this isolation of the needle in experimental data demonstrates that the current from the side plane of the needle is significant, and if we don't take away the entire injection but from the side wall, and we had it on the side wall, and if in case with generation of particles near the electrode or on the tip of the electrode, the entire charge that's formed in this area is not brought to the stagnant areas and is fully brought up to the counter electrode, moving along it. Therefore, we had an idea that it is eliminated fully and does not reach these areas. And as for the complication of the model, I've already mentioned that the attempts to consider some additional effects is something that we'll make in my further studies. Anatoly, it seems that Andrei did not answer all the questions. Well, mostly he answered all because my questions are sometimes repeated but in different variations. The main point that worried me, it was the one that you should be very exact in your models, and you should consider the microscopy of the process, because those injection functions that I considered in due time, they could be introduced based on the correct model of electrochemical act. And here author does not even mention this process of this act of charge formation. So I believe you should write down the reaction, introduce this constant definition, then the mass activity law, so as all the kinetics that is used when you study the charge formation on the surface of semiconductors or metals. That's the classical theory, and you should have used it. So this all is my main point. So you can use numerical methods or experimental explanations of hysteresis events. So everything is concentrated on this point, because author does not essentially consider the passage through the electron system. He considers the formation of charge, of impulse charges, on a small period of time when they move. That's an interesting thing, and that's important, sure enough. But the model that he used, he calculates for the entire system, but the system is quite far away from the experimental things. Therefore, certainly there are certain contradictions in numerical methods and in problem setting. Every time I remind about that, and Andrei understands that. He answers more or less correctly. He understands the drawbacks of his model, and the most important thing is that the methodology that he devised, I don't have comments on it. Moreover, I just support it with all the ideas. and I recognize this model. Thank you very much, Anatoly. As far as I understand, you're finally satisfied. Yes, the goal was quite complicated one. Yes, exceptionally. It is an exceptionally hard goal. So, please, Professor Karamennikov, you have the floor. Thank you. I didn't hear well, therefore I won't go into details. We hear you well. Okay. So you don't hear me well. We hear you quite well. Okay. Sometimes my connection interrupts. Okay. As for this mandatory points, they were already given by my colleagues, therefore I won't dwell upon them. I'll shift to my remarks, if I may. As for my remarks, some articles of scientific novelty seem declarative. In particular, Article 2, you declare a new mode, but where do you find this novelty? It's hidden. It's not given in detail. And these comments can be used for points 2 and 3. So I believe you should have formulated the scientific provision that was offered for the first time. Second point, literature overview is quite short. It takes just 6 pages. I believe that it's not correct. And you see, in our field of high voltage conductivity, we had Professor Felicity, an exceptional scientist, and he wrote a lot about these basic points. He invented them, he offered them, and you did not mention Professor Felicity. Third point. When calculating the currents, rates, and other parameters of high voltage conductivity, you give specific values of the density of space, charge, and time, and so on, but there are no parameters of the electrode system and even the voltage value. I missed, or maybe I missed it. Maybe it was hidden somewhere. Fourth point. It's unclear. Why do you introduce this new definition of high voltage current passage when we know this widely used term, high voltage electroconductivity? That is quite clear, quite understandable. So I see no need to introduce the new term. Then, other comments on physics. When considering the experiments on studying electroconductivity, you voice a provision on the role of the particles. You did not prove it. And also provisions on evaporation that are not proven as well. On the change of temperature, also no proof here. So you should have given some kind of assessments that it's indeed the case and that these processes really take place. And as for evaporation, everything will be defined by diffusion. So evaporation from the surface can easily happen, but you should have a diffusion from the volume, and that is quite a long-term process. And these time minutes that you give, it won't manage to happen. So there are other processes that happen, as I believe, and you should have considered them. Then, I won't voice question 6 because we've already discussed it. Question 7 was on the graphs. I'll miss it as well. And as for the filaments, certainly filaments may play a role, but you should have supported it experimentally, because it's quite easy to do that. Organize a filtration, And we've held such experiments. We just filtered everything and then considered and saw these formats in the microscope, how they were moving in this gap. So this could be explained. Maybe the explanation that you gave, maybe it is relevant, but you should have proven it. And the last point, we've already discussed the physical mechanisms of injection. That there is no physical substantiation. I won't dwell on that. Yes, I believe that's it, because I've already mentioned the other ones. Because there are these nuances on physical substantiation. So these are my points, and to sum up, regardless of the comments that I've given, I should say that the dissertation complies with the requirements of the Higher Attestation Commission, as well as the candidate for the degree that complies with all the requirements. And certainly, Mr. Sitnikov deserves the academic degree. That's it. Thank you very much, Sergey. Andrei, please, you have the floor. Thank you very much for the questions. I'll try to answer them. As for the novelty of the second point, the definition of capacity, I'll flick to it. The basic novelty is that the impulse that we use to calculate the capacity of the system remains in the oscillograms of the current and the voltage. Therefore, we see these oscillograms of the parameter of the system in this oscillogram, its electric capacity. Therefore, this impulse can also be used to give some other positive effects, but the key point is that we have it, and this impulse, this capacity, is recorded for every measurement, even if something happens between the measurements and the capacity, for example, changed, for example, the wire shifted, it will still be registered as a new capacity. Yes, that's clear. But, well, I don't disagree that there is novelty, but you should have formulated it correctly, because as for this formulation, wording that you have, I believe it is not quite correct. Dear colleagues, I beg your pardon. Konstantin went somewhere. Anatoly Ivanovich left. Therefore, we need to make the fourth break. Colleagues, we are about to continue. I need your advice to make the decision. Anatoly, unfortunately, did not come back, and I'm afraid that there are some technical problems that he has, and we can't establish a connection with him. Therefore, I offer the following thing. Our board is made up of 6 people. Andrei Klicherov is absent because he's ill. Anatoly, well, we missed connection with him. We lost the connection, but still we have 4 members of the board in place. Therefore, we have a quorum, and we can continue. I offer to continue our session. If we will manage to restore the connection with Anatoly, unfortunately he won't have this chance to vote. But there are 4 of us anyway, and our decision will be valid. So I want to ask any of you if you support my point. Can we continue? Please, Konstantin, what's your opinion? Nikolai, I just don't feel, I respect Anatoly very much, but unfortunately I believe we have to continue because our Polish guest has to voice his review as well. We shouldn't wait that much. Yes, yes, unfortunately we're going along the alphabetic order. Sergei, what about you? Yes, I believe we should continue as well. And he managed to give his opinion, therefore I believe we can continue. Professor Mazarachik, what's your point? What's your opinion? Professor, we don't hear you well. Can you please tell us louder? Should we continue?
I agree with Mr. Chairman that we should continue our meeting.
Да, я согласен с председателем, мы должны продолжать. Okay, Andrei, you did not stop answering. Yes. Thank you very much. I continue. Next question was on the literature overview. I think it is that the literature overview starts with the very introduction, and the literature is given in every chapter, so I give the references in every chapter in the most convenient places. And as for the search of literature, I used the reference basis of Scopus and Web of Science, and I've chosen the literature that was published in indexed sources, in peer-reviewed sources. And as for Professor Felici, there is one reference, number 15. I give it to these scientists. Certainly these are numerous references, but I have one at least. So, Andrei, is it that? Yes, I just try to remember. What else? Well, in all times the person should have written down the questions if he can't remember them. Yes, but you were given them in advance. And Andrei, I believe, is a bit relaxed about the questions of the opponents. Okay, as for the mechanical inclusions, you cannot diagnose them like that using the current characteristics. In our work we don't give it, but we simultaneously diagnosed we had this visual checkups of the liquid, and we've recorded it on the video. And as for the concentration and evaporation of admixtures, we simultaneously registered the conductivity of the liquid in order to control that it remained intact. Okay, you controlled. And these processes were not estimated. yet still you consider that they comply with the changes that you had. Yes, I agree. It turns out that as for the mechanical inclusions, this process is a random one, and it's hard to assess it. Okay, it's clear. So I'm not talking about assessments. I'm talking about the temperature, about evaporation. So these are the assessments that you should, that you had an opportunity to perform. And I believe your explanations won't do there. Yes, as for the assessment of the temperature, it was carried out only when we started the heating, when we tried to define whether this heating could be sufficient in order to increase the current so much, and as for other assessments, they were not carried out, indeed, and they were not included in the work. And in my future work, I'll try to give these assessments for all such manifestations. Okay, Sergei, are you satisfied? Well, certainly he partially agreed, and I don't disagree with that. Okay, okay. Now I give the floor to Professor Mizarachik. Please, Yerzy, you have the floor.
Mr. Chairman, distinguished members of the session. Can you hear me?
Professor, can you speak a bit louder, because it's very hard to hear you?
Mr. Chairman, distinguished members of the Dissertation Board. It's okay?
No, Professor, louder, because we can't hear you.
Mr. Chairman.
Yeah, that's okay, that's great.
I'm very sorry.
Я прошу прощения.
My microphone is just very close to my mouth.
Микрофон будет тогда очень близко.
Oh, sorry.
Еще раз прошу прощения. Уважаемый председатель,
English members of the
уважаемые члены диссертационного совета,
I will focus on
я
main points
сфокусируюсь на основных моментах своего обзора.
In my opinion, the dissertation mainly aimed at justifying usefulness of the so-called dynamic current voltage characteristics
Итак, диссертация посвящена экспериментальному исследованию процессов
of the low conducting liquid system for describing and analysis of the current flow through the low conducting liquid under the voltage condition. Was it translated? Hello?
Professor, we have a problem. Okay, Professor, you can continue, but please be closer to the microphone.
But, can you hear me now? Hello?
Yes?
Can you hear me?
Yes, we can.
So, once more. As I told,
Итак, еще раз, как я сказал,
the dissertation
диссертация
was mainly aimed at
в основном была нацелена
of the so-called dynamic current voltage characteristics of the
на
local
подтверждение характеристик
system for
низкопроводящих систем и была направлена на описание на описание процессов в условиях высокого напряжения. Господин Ситников в своей работе представил самые характерные примеры из оригинальных исследований, которые поддерживают его гипотезы о возможности использования динамических вольт-амперных характеристик для описания процессов электрического заряда и переноса ионов в слабопроводящих жидкостях в условиях высокого напряжения. Все хорошо, потому что я не слышу перевод. Professor, I translate to the Russian channel. That's okay, you can continue.
Мои коллеги,
Distinguished colleagues, as far as I believe the connection is not very good, I believe we should announce the technical break number 5. Yes, and try to improve. Professor, unfortunately, we have to declare a technical break. We'll try to restore everything.
I understand, but look, for me, it would be better if I can't hear your translation, okay?
вы просто пропадаете иногда. Я угадываю, что вы говорите по губам.
Yes, because sometimes we lose the connection and I have to guess what you say, judging by the movement of your lips. Therefore, we have to announce the technical break number 5, just to resume the good connection. Yes, it seems that the problem is on our side. Anatoly, we're glad to see you returned. Yes, the thing is that I have to be present at 2 panel sessions at a time. Yes, but according to the order, we were very glad to work with you together. But the fact that you left is it means that you won't be able to participate. But we still know your opinion. Therefore, we'll take it into account. Professor, we proceed. You can continue.
Can you hear me now?
Yes, but a bit closer. You can continue.
I'm very sorry. I'm a bit lost.
Да, прошу прощения, немножко потерян. Итак,
The original results
оригинальные данные которые были представлены в диссертации, были получены в результате экспериментальных исследований и компьютерного моделирования, проведенных автором. На основе этих данных автор представил подробную интерпретацию динамических вольтамперных характеристик, связав ее с различными механизмами образования заряда и передачи тока, в том числе с конвекционным током, вызванным электрогидродинамическим течением в слабопроводящей жидкости при наличии высокого давления, высокого напряжения. С моей точки зрения, научная новизна результатов в рецензируемой диссертации заключается в следующем. Впервые экспериментально определены основные факторы, влияющие на протекание электрического тока в слабопроводящих жидкостях в условиях высокого напряжения. Господин Ситников. A bit louder, professor, a bit louder.
Mr.
Вот так.
Presented his scientific results in the international journals, indexed in the databases of Web of Science and Scopus. And now you can hear me or not?
Yes, we do, Professor. You can continue.
Okay. So, okay.
И эти работы уже были признаны международным сообществом, и результаты, полученные господином Ситниковым, были достаточными для того, чтобы их представить на международном симпозиуме по электрогидродинамике в Канаде и на следующем международном симпозиуме по электрогидродинамике, который проходил в Санкт-Петербурге. На этом международном симпозиуме господин Ситников получил диплом за лучший постер среди молодых ученых. А сейчас я хотел бы задать И как раз этот вопрос я задаю в последней части моего отчета, потому что если бы я добавил их сейчас, может, диссертант их не так хорошо запомнит. Могу я это сделать?
I prefer to ask these questions at the end of my talk, because it will be better to remember these questions before we had some problems that some questions were missed. Can I do it?
Да, конечно.
Yes, certainly.
Спасибо. So, finally, in my opinion, the dissertation of Mr. Sitnikov, titled Experimental Description of the High Voltage Electric Current Passage through Low Conducting Liquids Based on Dynamic Current Voltage Characteristics, fulfills the requirements for granting a PhD degree of Physical and Mathematical Sciences, ученая степень кандидата физико-математических наук, established by the decree приказ number 6821 on the order of granting degrees in St. Petersburg State University о порядке присуждения ученых степеней в Санкт-Петербургском государственном университете. After analysis of the doctoral dissertation, I'm convinced that Mr. Sitnikov deserves to be granted with a PhD degree of physical and mathematical sciences, ученая степень кандидата физико-математических наук in specialization 010413 electrophysics, electrophysical installation. And now I would like to ask Mr. Sitnikov on comment on the interpretation of dynamic current voltage characteristics for various rise rates of the amplitude of the sawtooth voltage applied to the low conducting liquids. And I would like to know his comment on the transient physical phenomena in low conducting liquids under the sawtooth voltage for various voltage amplitude rise rates. In simple words, what we gain or what we lose when the rise time is very low, or when the rise time of the voltage amplitude is very high. Are my questions clear to you, Mr. Sitnikov?
Yes, thank you very much. Thank you very much, Professor. We understood your questions. Thank you.
Thank you very much.
Andrei, please answer the questions of Professor Mazarochik. Thank you very much for the question. The difference in speed of the modulation of the signal and different time of impact with maximum voltage means that between these values of current on one characteristic, on the one hand, there is a certain period of time passes, and on the other hand, at this time, we see the impact of high voltage. And thus, accelerating the characteristic, we lose...
Hello, excuse me. What number is the figure you show? Because I can't see very well, but I can use my files of your presentation. Figure number?
17.
17, figure 17, Professor. Slide 9, that's slide 9 and figure 17.
Yes, 9, 7. Yes, thank you very much.
So I will repeat from the beginning. The different speed of modulation is, on the one hand, the different time between the values of the current when we have the same difference in potential, and on the other hand, that is the different time of impact with high voltage. Therefore, when we accelerate our characteristic, we lose the information on the input of additional transition processes. So we have a process of formation of the charged jet, and it takes place quite quickly. And we register it during the registration of characteristic. But as for other processes, like degradation of this pure metal liquid, heating, or something else, they are eliminated. When we accelerate the characteristic, we get a photo of the state of liquid, the so-called photo of the state of liquid at that period of time. And the instant values of conductivity for this cell of liquid and metal. Professor, are you satisfied with the answer of Andrei?
Well, to some extent, yes. To some extent, yes.
Mm-hmm.
But can you give some data, some numbers relating to the rise time of the voltage to relaxation time of some processes in the liquid. I mean,
Да, спасибо.
Yes, I got it. I got it. Yes, I can comment, Professor. As for at the time of the growth of voltage from 0 to 25 kilovolt with a pace of change of 5 kilowatt per second, then this growing time up until the maximum point is 5 seconds. And as for other time periods of transition processes, as the modeling demonstrates, the process of jet formation takes much less than decimals of second, and the transition processes, additional processes that are observed in this characteristic in evaporation, in degradation, and other processes, they take tens or hundreds of seconds or even hours and sometimes even days. Therefore, as for the time periods, there are these additional transitional processes that may emerge. They emerge on on more lengthy periods of time.
Yes, but I would like to have some practical information from your results. For instance, if you do have any table or information like that, for instance, if the rise time of the amplitude of the voltage is, say some kilovolts per several, well, say 1 kilovolt per second, if then we don't lose such and such processes. If the rise time is between A and B, then we lose information about another processes, and so on and so on.
Да, спасибо, я понял вопрос.
Yes, thank you, I got the question. Unfortunately, I have no such information, and that is connected with the fact that to a large extent we may have variations of different processes, for example, the cooling or evaporation and emission, and other processes. Even accumulation of the charge in the volume significantly depends, this time of accumulation significantly depends on the system chosen. And if we draw analogies, the relaxation time of the charge may be comparable to the time of the growth of voltage at a characteristic value, for example, of 100 volt. But in this work, we did not give these results because they are not easily systematized due to the difference in time. If we summarize, in the dynamic current voltage characteristic regime, we can experimentally say that the time of passage of inter-electron gap is significantly smaller, but talking about all other events won't be general, maybe it won't be correct.
Okay, thank you very much. I'm satisfied with your answer.
Thank you very much, Professor Mizarachik.
Thank you.
Now I'm going to read the review of Andrei Klecherov, that is the member of our dissertation board, who is unfortunately not with us because he fell ill. At the beginning of his review, Andrei describes the relevance of the thesis and he believes that the work is quite relevant. He describes the credibility of results and says that the provisions and the results are substantiated. He lists the results of the work in chapters. I won't do that because we've already discussed that. And he has certain remarks. The first remark, in chapter 3, you demonstrate how these peculiarities of dynamic current voltage characteristics correspond with cataphoretic conductivity. And you mentioned the effect that leads to the distortion of dynamic current voltage characteristic on this adhesion of particles to a high voltage electrode. In chapter 4, when you describe figure 414, you use this term cataphoretic conductivity, but here you mean the adhesion of particles to electrode, and as a result we have this mistake. There are two different mechanisms how the particle can stick, can lead to the change in registered current, and it's unclear what you imply to here. Second comment, in chapter 5, when you describe the method of the restoration of injection function, you do not describe how you define the coefficients of the injection function for the next iteration. If you have experimental data and the modeling results for initial approximation, then how you calculate the coefficients for the next iteration, and how you got these values of coefficients represented in the table 1, section 535. Regardless of the drawbacks, the thesis by Andrei Sitnikov, titled Experimental Description of the High Voltage Electric Current Passage through Local Ducting Liquids based on Dynamic Current Voltage Characteristics, meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Sitnikov, the candidate, deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 010413, electrophysics and electrophysical installations, and Article 11 of the above-mentioned order is not violated. And that was the review of Andrei Kulcherov. Thank you very much, Mr. Chairman. As for cataphoretic conductivity, in literature we do not have this division when cataphoretic conductivity should be used to call the transfer of the charge along with the particle, and when the particle leads to the increase of high voltage mechanisms. So I haven't seen that, and maybe the use of this definition for two separate processes is not correct, and it would be correct to use it in case when the charge is transferred along with the particle, not when the particle is the continuation of the electrode. That's as for cataphoretic conductivity. And as for the methodology of restoration, the dependency, I looked for the dependency by the choice, because I didn't have a kind of reverse action or approximation of a curve with a curve, because out of the current values that we receive when we calculate on console, it's hard or impossible to get the values of coefficients that are defined by the function that is gives a non-linear contribution along the surface of the electrode. And here, to simplify, I did not offer any methodology for this action, and the coefficients were selected manually. But even this approach gives us a good correlation of experimental and modeling data. Thank you. Well, let's hope that Andrei would be satisfied. And now my review. The last review of the members of the dissertation board. And I'll use the example of my colleagues and shift to my comments at once, because we've already heard the discussion of the work. So I have the following comments, and sometimes they coincide with the comments of Konstantin and Sergei, yet still I read them out fully in order to be more strict. First, from my point of view, when writing a thesis, the experimental part of work was sacrificed to the calculation part, though the first one contains original solutions. And you should have given experiment more attention, because in the recent time the works that have experimental data are scarce. Second point. As a reason of a distortion of current characteristics, you see the accumulation of the space charge in stagnant areas of the cell. At the same time, the movement of space charge in liquid is the effect on the registration of which we see the foundation of the dynamic current voltage characteristic, and it is unclear how author defines these areas where the change in space charge is a matter of interest, in which accumulation of this space charge becomes from the ones in which the space charge becomes the distortion reason. Third, as an element of novelty, you give the new method of the definition of capacity, but in the literature review you don't have this review part to define this capacity. Therefore, it's hard to understand the level of novelty of this achievement. Fourth, the same characteristics, currents and flow speeds are registered experimentally and calculated numerically. Therefore, the definitions to figures are quite complicated to understand. And fifth, in the text of dissertation, when you describe the results, you don't give the references to your works, and it really hinders the understanding of the place of the conducted research and the contribution to the solution. And the last remark, the main conclusions are given rather vaguely. In conclusion, I believe you should have formulated them in a more exact manner. But still, it does not compromise the high scientific level of the studies. The major results are published in scientific journals recommended by the Higher Dissertation Commission. All the articles are indexed in Web of Science and in Scopus, and also these results were delivered at the international conference. The results of the work are quite credible. So that is a finished study, and it meets the requirements of the Order of St. Petersburg State University on the procedure of granting academic degrees. And Article 11 of the above-mentioned order is not violated, and I believe that Andrei Sitnikov deserves the academic degree of the candidate of sciences in physics and mathematics and specialization 010413 electrophysics and electrophysical installations. So, please answer. Yes, thank you. As for the analysis of the novelty, indeed, in this work I do not give sufficient literature review in this regard, and indeed I should have paid more attention to this point. But the thing is that in electrohydrodynamics, this point has limited attention, and I did not manage to find sufficient literature sources for that. And as for the interest areas of and space charge, that on the one hand is a field of interest, and on the other, in another point, it is a stagnant area. I agree that it is impossible to strictly outline which area gives what, but in the central area of the jet, where the charge goes along with the jet of liquid, it transfer leads to the rise of current value. And the charge that we have in the volume leads to the reduction of the electric field intensity on the active electrode, and it leads to the reduction of the current characteristic. And the charge that is located in the side part and has no positive contribution to the current, as well as the charge that is located evenly under the tip of the electrode. It also reduces the electric field intensity on the active electrode. Therefore, here you can't refer it to the area of interest, because this is one of the types of current passage in the liquid. And from the point of view of current that goes through the system, this charge that is reducing the electric field here and has no positive contribution to the current, it has a negative effect over here, considering the drop in current. And as for publications, indeed, it's not that well formulated what publications are referring to which data. And this can really be a bit confusing to the reader. Therefore, here I give the table of some of the key publications that indeed have those data delivered in the work. That are directly connected with the topic of study. And as for the conclusions, in conclusion that I have in my work, the provisions are not that well formulated, because as for the conclusions on the work, they are actually the provisions that were brought up for the defense. And as they were already written, they were not duplicated once again in conclusion. Okay, thank you, Andrei. Let's think that I'm satisfied with your answers. Anyone, not the members of the board, is anyone willing to speak out? No one? Natalia, any external questions? No, none? Okay. I beg your pardon, but I am to ask the members of our dissertation board, or that are working remotely, if everything was clear, if everything was well heard. Certainly we had communication problems, but I hope that you managed to hear the overall talks. No problems with that, none.
From my side, it's not no problem, because I could hear and see very well, but my dog was a bit disaster. I'm sorry for that.
Ничего страшного.
Yes, that's okay. Thank you, Professor. And now I give the floor to the thesis supervisor of Vladimir Cherkov. Please, you have the floor. Thank you very much, Nikolai. I'll be very short. I've been working with Andrei for 8 years already. I started working with Andrei when he was a student. And for this period of time, the main association that I have is reliability of experimental data. Everything that he gets, he is quite critical about the analysis and all the data that he provided in his reviews and the text of dissertation. Everything is really reliable and checked several times. That's the main characteristic of this candidate. And he also demonstrated that he has a very good experimental capability, and he also wrote a good functional program on the processing of experimental data. That is the program that we are continuously using. Other researchers are using it as well, and we use this program and methods to diagnose the real samples of transformer oil, and that's a good contribution from Andrei to the work of our group. And once again, I would like to emphasize that the problem of getting reproducible characteristics of current passage in liquid dielectrics is quite complicated, and global organization SIGRE several years ago created a large group that worked for several years and did not get a satisfactory result. And here we use high voltage regime, and we managed to find the cases when the characteristic is stable. And as for the results that was received jointly with Andrei, we performed a grant of the Russian Foundation for Basic Research, and I had an invited talk at the Canada conference, and Andrei's data laid the basis for that, and Andrei also got a diploma for the best report at the International Symposium on Electrohydrodynamics. That's it. Thank you very much, Vladimir. I would like to ask once again if anyone else is willing to speak out. No one? Okay. Therefore, we shift to the voting procedure, and I would like to ask the members of the board if we have a need to organize a closed talk when we ask everyone to leave, if we want to develop a joint opinion, or we don't need this closed talk because the opinions were already voiced and clear. So what's your opinion, colleagues? So no need to organize a closed session. Yes, Sergey, what about you? Yes, I believe we can discuss it openly. No, I mean that before the voting we can have a secret ballot. Maybe we have certain points to discuss without the presence of the candidate or the thesis supervisor. If everything is clear, we can shift to voting at once without this closed secret balloting. So if we can proceed in an open manner, we can vote at once. So if there is no need to organize this closed voting, we can shift to the vote straight away. So I need your opinion on that. Yes, let's shift straight away. Yes, let's vote right now. Okay, Professor Mizarachik, shall we vote right now?
Yes, I agree.
Okay, хорошо.
I vote now.
Okay, thank you. Okay, I'll go step by step. Unfortunately, Anatoly, we know his opinion, that it's positive, but formally I don't take your vote into account, unfortunately. But Anatoly has already voiced that, and he has already submitted his review. So considering the fact that we know the opinion of Anatoly and Andrei, and they are positive, I ask the members of the board to vote. Konstantin, what's your opinion? Do you say yes to the award of the academic degree? I support the award of the academic degree. As far as I know, the dissertation is complies with the requirements, and I would like to particularly mention that my opinion is the same as yours, because now there are very limited number of dissertations with good experimental data that make good contribution to the development of science, electrophysics. Therefore, I support the award of the academic degree. Thank you, Konstantin. Sergey, what about you? I also say yes. Professor Mizarachik, what's your opinion?
I support
Спасибо.
awarding the title.
Thank you. And I also vote for the award of the academic degree. So the results are as follows. Out of the 4 members of the board that have the right to vote, 4 voted for the award of the academic degree, no one voted against, and no one abstained from the vote. Therefore, the decision on the awarding of the academic degree of the candidate of sciences in physics and mathematics in specialization 010413 electrophysics and electrophysical installations is made. Once again, distinguished colleagues, due to the protocol, I have to ask you once again, because the vote was the most important point and it was held remotely. I wanted to ask if you have any comments or any remarks on the procedure of the holding of this vote. No? No comments? No? Okay. Okay, thank you. Well then, Andrei, you have the floor for the final remarks. Thank you very much, Mr. Chairman. Initially, I would like to thank all the members of the Dissertation Board. The reviews and those comments that you gave were really useful in the preparation of my report and also for the future. They allowed me to take a different look at the work that I've already done. And sure enough, I will keep all the comments and I'll try to take that into account in my further studies. And sure enough, I would like to thank my thesis supervisor for his exceptional help and for his role in this work. I would like to thank him for the freedom of scientific discussion, for the freedom of choice that was provided when I chose what exactly do I want to defend in my dissertation, for this fruitful and constructive process. So I would like to thank for that my thesis supervisor for that as well, and I would like to thank everyone who helped me, my friends, my relatives and my colleagues who participated in the process, who helped me in the preparation of the thesis and did not intervene at some points. Thank you, Andrei. On behalf of all the members of the Dissertation Board, I would like to congratulate you on the successful defense and on the award of the degree of the candidate of sciences and physics and mathematics, and I would like to wish you success in the future, because as far as I understand, the field of studies is already defined, the goals are set, and you understand what you should do. Therefore, I would like to congratulate you once again and wish you further success. I would like to thank all the members of the Dissertation Board. It turned out that today everyone is participating remotely, is working in a remote mode. Therefore, I would like to thank you for taking time. And I would like to thank Professor Mazarachik in particular, who, regardless of the problems with connection, still managed to break through and gave his opinion to us. Therefore, I would like to thank everyone. I thereby close the meeting and I ask to turn off the broadcast.